Contributors in the field of science, 200 BC to 300 BC. Chrysippus of Soli, circa 280 BC, circa 206 BC. Chrysippus, a Greek philosopher and logician, is often referred to as the father of propositional logic. He created foundational logical systems that later influenced methodologies used in scientific reasoning. His theories on cause and effect were pivotal in understanding natural phenomena and laid the groundwork for determinism. Chrysippus also delved into physics, proposing theories on the structure of the universe and the organization of matter. His cosmological views emphasized the interconnectedness of all things, which inspired future studies in both natural and social sciences. He wrote extensively on various topics, producing over 700 works that influenced Stoicism and later scientific thought. Chrysippus argued for the necessity of empirical evidence to validate theoretical claims, emphasizing observation and critical analysis. His intellectual contributions extended to ethics, where he explored the role of logic in human decision-making and behavior. The rigor of his logical frameworks profoundly shaped Roman-era legal and scientific advancements. Despite limited biographical details, Chrysippus's insistence on systematic inquiry and observation solidified his position as a key figure in ancient science. His contributions provided a methodological foundation that bridged philosophy and science. His influence persisted through the works of later thinkers, exemplifying his enduring legacy in philosophy and logic. Chrysippus's writings introduced techniques that were instrumental in formalizing arguments, aiding disciplines like mathematics and physics. His unique ability to synthesize abstract ideas with practical inquiry remains a cornerstone of scientific exploration. His work also advanced early studies in human psychology, focusing on how logical reasoning could resolve internal conflicts. He emphasized that science and philosophy should collaborate to address humanity's deepest questions. Chrysippus's influence reached beyond his era, shaping the intellectual traditions of the Renaissance and beyond. Diophantus of Alexandria, circa 200 BC, circa 284 BC. Diophantus, known as the father of algebra, made monumental contributions to mathematics, especially in number theory and equations. His groundbreaking work Arithmetica presented methods for solving both determinate and indeterminate equations, creating a foundation for modern algebra. Diophantus introduced a symbolic notation system, streamlining mathematical expressions and calculations. His focus on rational solutions and innovative techniques influenced luminaries like Fermat, whose famous last theorem was inspired by Arithmetica. Diophantus explored cryptographic methods, using equations to encode information, which laid the groundwork for modern encryption. His mathematical theories found practical applications in geometry, architecture, and astronomy, demonstrating their interdisciplinary relevance. Diophantus also advanced the study of prime numbers, devising techniques that are still studied in number theory. His intellectual legacy shaped both Islamic and European mathematical traditions during the Middle Ages and Renaissance. Despite scant details about his life, Diophantus's work exemplified the power of mathematical abstraction to solve real-world problems. By blending pure theory with practical applications, Diophantus transformed mathematics into a versatile tool for exploration and innovation. His ability to innovate methods for solving polynomial equations highlighted his visionary thinking. Diophantus's work was foundational for the transition from classical mathematics to modern algebraic techniques. His focus on blending theory with application showed how mathematical thought could impact diverse fields, from economics to astronomy. Diophantus also created methods for solving fractional equations, which expanded the possibilities of mathematical problem-solving. His influence on cryptology provided secure systems of communication that predated modern codes. His work emphasized the beauty of mathematical order, inspiring generations of scholars. Erasistratus, circa 304 BC, circa 250 BC. Erasistratus, a Greek physician and anatomist, is renowned for his pioneering studies in anatomy and physiology. Co-founder of the Alexandrian School of Medicine, he conducted systematic dissections to uncover the workings of the human body. Erasistratus distinguished between arteries and veins, although he mistakenly believed arteries carried air. His theories on the heart as a pump represented an early understanding of cardiovascular physiology. He also explored the nervous system, differentiating between sensory and motor nerves, an insight that influenced future neurological studies. Erasistratus emphasized mechanical explanations for bodily functions, marking a shift from mystical to empirical medicine. His work on digestion proposed that it was a mechanical and chemical process, foreshadowing modern gastroenterology. Preventive medicine was a key aspect of his philosophy, with recommendations on diet and exercise for maintaining health. Erasistratus's teachings influenced Roman and Islamic medicine, ensuring his legacy endured. His focus on experimentation and observation laid the foundation for evidence-based medical practices. Though details of his personal life are sparse, Erasistratus's work represents a major leap in the scientific understanding of human anatomy and physiology. His commitment to explaining biological processes through observation and hypothesis testing marked a transformative approach in ancient medicine. Erasistratus's influence extended to pharmacology, where he advocated for a systematic study of medicinal substances. His model of health maintenance integrated science with practical advice, forming the basis for many public health principles. He also theorized about the brain's role as the center of cognition, ahead of his time. His anatomical studies offered new perspectives on human resilience and adaptability. Hipparchia of Maronea, circa 325 BC, circa 250 BC. Hipparchia of Maronea, a Cynic philosopher, played a unique role in bridging ethical philosophy with scientific thought. Her philosophical outlook emphasized living in harmony with nature, an idea that foreshadowed modern ecological perspectives. By advocating critical examination of natural processes and their alignment with human behavior, she encouraged intellectual inquiry that extended into scientific domains. Hipparchia participated in public debates, challenging societal norms and promoting reason over tradition. Her arguments often highlighted the interconnectedness of human life and natural systems, influencing the way natural philosophy was approached. Although her writings are lost, her ideas were preserved through the accounts of contemporaries. Hipparchia explored happiness, arguing that it arises from simplicity and rational living rather than material wealth. Her work inspired a critical and rational approach to examining the natural world, fostering a spirit of inquiry essential for scientific progress. Her legacy as one of the earliest female philosophers demonstrates courage and intellectual resilience in a male-dominated field. Hipparchia's life and teachings continue to inspire discussions on ethics, logic, and the integration of philosophy with science. Her advocacy for simplicity and sustainability resonates with modern efforts to address environmental challenges. Hipparchia's focus on community well-being showed a keen awareness of societal and ecological interdependence. By emphasizing natural harmony, she influenced early approaches to studying ecosystems and sustainable living. Her efforts to link ethics with natural sciences remain foundational to interdisciplinary studies. Strato of Lampsacus, circa 335 BC, circa 269 BC. Strato of Lampsacus, a Greek philosopher and head of the Lyceum, made significant contributions to natural philosophy and experimental science. Known as Strato the physicist, he emphasized empirical observation and experimentation to understand natural phenomena. Strato conducted experiments on falling objects, air pressure, and vacuums, laying the groundwork for ideas later formalized by Galileo and Newton. His materialistic explanations of natural events rejected supernatural causation, emphasizing observable and logical causes. Strato's studies in biology examined the growth and functions of living organisms, linking his findings to broader theories about the natural world. His work on the mechanics of motion introduced principles that became fundamental to physics. Strato also explored the structure of the cosmos, theorizing about natural processes that shaped the universe. His interdisciplinary approach to science integrated philosophy with empirical methods, influencing later scientific traditions. Although his personal life remains obscure, Strato's intellectual rigor and innovative experiments cemented his reputation as a pioneer of the scientific method. His emphasis on cause and effect relationships inspired advancements in experimental techniques across disciplines. Strato's detailed observations of natural motion influenced early theories of energy conservation. His theories on air as a medium for motion highlighted the complexity of understanding material interactions. His curiosity about the origins of life and biological evolution pointed to the earlier seeds of evolutionary thought. Strato's insistence on measurement and repeatability became core tenets of scientific methodology. If you found this video interesting, don't forget to like, share, and subscribe for more. Stay tuned for the next chapter in our series on revolutions and progress that shaped our world.